back with my new lecture for Standard 10. I welcome you all to my noble classes. As I told previously, we are going to start lectures for Standard 9 and Standard 10. Two lectures I have already finished for Standard 9. Now it is beginning. Now it's time to start a lecture for Standard 10. As you all know, Standard 10 is very important for every student. In every student's life, Standard 10 is a turning point of life. And taking all this point into consideration, I have decided to start with Science 1 and that also first chapter of gravitation. Hope you all will like this video. Please watch the video till the end. Please do like, share and subscribe my video so that many students who are sitting at home but not able to study will get an opportunity to study new things through this online classes. So, I will start with my lesson gravitation. Now before starting with this lesson gravitation, let me tell you one story. Okay, I hope many of you all must be knowing this story, but still I want to tell that story again. There was one tree, okay, and under that tree was sitting one person. Now my drawing is not that good, so please don't consider as a drawing teacher. Just make an imagine or just imagine yourself while I am telling the story. So there was one tree and under that tree there was sitting one person. His name was Isaac Newton. Okay, many of you all have heard about his name, Newton. This Isaac Newton was sitting under a tree. And since he was sitting under a tree, he was reading a book. A book was there in his hand and he was reading. Now suddenly what happened? One apple, this was an apple tree, and one apple fell down. Okay, one apple which was there, it fell down in front of him. And Isaac Newton started thinking. Now I don't know why Isaac Newton was thinking, but if I would have been in his place, what I would have done, I would have taken that apple and I would have thanked God that please you gave me this apple, so thank you, and I would have started eating. But seeing this apple, Newton did not started eating. He started thinking, and he was thinking so deeply, and then the law came into existence known as Newton's law of gravitation. Now what he was thinking? He was thinking that why this apple fell down? Why this apple did not went on top? Or why this apple did not went to the left side or to the right side? Why did it fell down? The answer to the question was found out later, which was due to gravity. This apple, which was on the tree, it fell down because of gravity. Now what is gravity? Gravity is nothing but it is a phenomena in which two objects, for example, if I consider two objects, okay, I think many of you all have seen magnets, okay, in your childhood, you all must be playing with magnets. So consider this is object A and this is object B, okay, object A and object B. These two objects try to attract each other. Try to attract each other means what? They try to come closer to each other. So gravity is nothing but it is the phenomena in which two objects in the entire universe try to attract each other with a certain amount of force. I hope you all must be knowing what is force. Okay? Two objects, this is object A, this is object B. These two objects which are there, they try to attract each other with a certain amount of force. And this force is known as gravitational force. Okay, there are many kinds of forces. For example, you can say magnetic force, gravitational force, but now at the present we are going to talk about gravitational force. Now, when Newton was sitting under that tree, what happened is, here was Newton, here was that apple. Okay, now what happened? This is Earth. Okay, and this is apple. I hope you all are imagining what I am telling you. Okay, so this is apple, this is Earth. Now what does gravity say? Gravity say that two apple or some force on the apple, in the similar manner, apple will also exert certain force. Okay, apple will also exert certain force on it. And in this case, both the objects will try to come closer to each other. But if you observe, apple falls on the earth, but the earth does not go towards the apple. Why does this happen? If you observe, apple is very small, it is very tiny, but the earth is large. That means the gravitational force present on the earth is far greater than that of apple. That's why this apple which is there, it falls on the earth. Okay. There are many things on this entire universe which are attracting towards each other. Now for example, if I am standing on the earth, that means I am standing on the land, right? For example, this is land. Okay, and I am standing over here. Am I floating on top? No. Why? Because I am exerting certain force on the earth. Similar manner, the earth is also exerting some force on me. Due to this combination, I am able to stand on the earth. If you observe on the TV or on the internet also, if you find, moon does not have gravitational force. That means whenever you go and land on moon, you will not stand on the surface of the moon. What you will do, you will try to float in the air. But on the earth, if you observe, gravitational force is present. So what is the definition of gravitational force? The gravitational force definition is nothing but when two objects or when two bodies in the entire universe try to attract each other with a certain amount of force. Okay? Try to attract each other with a certain amount of force. This force is known as gravitational force. And let me tell you one thing, gravitational force is the weakest force of all. Okay? That is the weakest force. Now why it is weakest force? One example. This is Earth. Okay? This is Earth. Okay? Earth is exerting which force? Gravitational force. Now since Earth is exerting gravitational force, but we can launch satellites, we can launch rocket in the outer space, right? For example, satellite. Okay, if I want to launch satellite in the outer space, what I do? I have to go beyond this Earth's gravitational force. Then only I can launch a satellite. That means there are many satellites present in the sky. Every country, every nation has established its satellite in this space. That means we can easily escape the gravitational force. So gravitational force which is there, it is the weakest force of all. Now, why this gravitational lesson is important here? Because this gravitational lesson which is there, it comes under physics section. Okay, in the previous lectures only, in the introduction lecture only, I told you that science 1 consists of physics and chemistry. And this first lecture is only of physics. And when you go in 12th standard, after passing on 10th standard, you will have 11th standard. And if you choose science stream, for 12th standard, you will have this lesson. Some concepts related to gravitation. So if your basic concepts are clear in this year itself, it will not create a headache for you all in 12th standard. Okay. Now gravitational force I was talking about. Gravitational force. Now force is always denoted by F. Okay. All these concepts which I am telling, all are derived by Newton. Okay. Newton's law of gravitation, gravity. This phenomenon is given by Newton itself. Okay. So now when we are talking about gravitational force, force is denoted by the symbol F. Okay. Many scientific symbols are there. For example, velocity is denoted by V, mass M, density rho. Similarly, force is denoted by F. Now what did Newton said? Newton said that force, this gravitational force which is there, it is directly proportional to product of the masses. Don't get confused, I will explain everything. What is this directly proportional and what are these masses and all. Force is directly proportional to product of the masses and inversely proportional to the square of the distance between them. Okay, again I'll repeat the sentence. Gravitational force is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Now what does this mean? See one example. This is ball M1, this is ball M2. Okay, or I'll say this is ball A, this is ball B. Okay, this is ball A, this is ball B. Now what happens is, there is a specific distance between them. These two balls which are there, they have been placed at a certain distance from each other. Now since it is a ball, it will have some mass. Okay, it will have some mass. So I will say this mass as M1 and I will say this mass as M2. Now why this M1 and M2? I am just naming it. You can give anything, C, D, E, F, G, anything you can say. But since we are talking about mass, I will say mass 1 and mass 2. Now this is object A, this is object B. This object A is having mass M1, this object B is having mass M2. What does Newton's law of gravitation says that gravitational force, it is directly proportional to the product of the masses. Now what does this directly proportionality sign mean? Directly proportional means what? It has direct relation. See, force, it is directly proportional to M1 and M2. That means force, it is directly proportional. Directly proportional means what? It has direct relation with each other. Now see, if one quantity increases, direct proportionality sign indicates what? That if one quantity increases, for example, if I am increasing force, if my force is increasing, then my M1 and M2 will also increase. That means if my one quantity is increasing, automatically my second quantity will start increasing. Why? It is having direct relation. Direct relation means what? If one is happy, the other will also be happy. Similar way, when force is increasing, both the masses will be increasing. This is direct proportionality. What is inverse proportionality? See, inverse proportionality means what? I said force, it is inversely proportional to square of the distance between them. Okay, square of the distance between them. Instead of R, I will take D. Okay, I will take D. Consider it as D is the distance between the two objects. Now what I am saying, this gravitational force, it is inversely proportional to the square of the distance between them. That means if my force is increasing, my D will automatically decrease. When it is coming in the numerator section, always pay attention that it will increase. But when it is coming in the denominator section, if one quantity is increasing, the other will automatically decrease. This is the relation between direct proportionality and inverse proportionality. Now here what the statement is telling, that gravitational force, it is directly proportional to product of the masses. Product means what? Multiplication. Here is multiplication. That means M1 and M2 masses will be multiplied. M1 and M2 masses which are there, they will be multiplied and it is inversely proportional. That means it will come in the denominator section and this is the D is the distance between them. So it will be inversely proportional to the square of the distance between them. That means this D, you have to do its square. Okay. Now, till you understood? Now see the next. Now here direct proportionality sign is there. Please remember that these sums do come in exam. Okay. These sums are very important. It hardly comes for 2 to 3 marks. So please pay attention to this very carefully. Now if I give you value M1, M2, D, we can easily find out F. But what is this sign? This sign is never used in maths for calculation. So what we will do? We will remove this direct proportionality sign. Now how this direct proportionality sign will get removed? This direct proportionality sign will only get removed if we replace it by some other constant. For example, if we say if two boys are there, okay, both are fighting, okay, both are fighting with each other, and what happens? The entire class which is there, he says that please stop fighting. One will only stop fighting if a stronger person is there in front of him, right? Only if a stronger person is there in front of him, then he will stop fighting. Here also what happens? Direct proportionality sign. This proportionality sign will only go from here when we introduce a stronger person only. So what did Newton did? Newton introduced a stronger person. Who was the stronger person? See, F, instead of this proportionality sign, he gave is equal to, and one stronger person he introduced, that is gravity. Okay, gravitational constant, and then m1 m2 upon d square. Okay, that means gravitational force, it is equal to product of the masses and inversely proportional to the square of the distance between them. For 1 mark question also this question comes, that define gravitational force. So instead of remembering the entire statement, you can only remember this formula. What does this formula say? Only just remember F is equal to G m1 m2 upon d square. How we will define it? Gravitational force is directly proportional to m1 m2, that is product of the masses, and inversely proportional to the square of the distance between them. Now this G which is present over here, it is known as gravitational constant. Okay, in the beginning only I told you that this proportionality sign will only go if you introduce a stronger person. And this G which is there, it is always stronger than this proportionality. So this G which is there, it is gravitational constant. You do not need to calculate the gravitational constant. It is always given, and its value is 6.67 into 10 raised to minus 11 Newton meter square upon kg square. Okay, Newton meter square upon kg square. This is the value. This value should be kept in mind. It should be learned. 6.67 into 10 raised to minus 11 Newton meter square upon kg square. This is gravitational constant. For solving the numericals, G is already given to you all, mass is given, second mass is also given, distance is also given. Only you have to calculate this F. Okay, in today's lecture this much is there. In the next lecture we will find out how this unit came and some numericals based on this. If you like the video, please share it with maximum students. Please do subscribe it. Thank you.